Hello, and welcome to our presentation. My name is Chris, and today myself, Ryan, and William will be presenting an analysis we conducted covering crime in Washington, D.C. I will start us off with a brief introduction to public safety in D.C. Washington, D.C. has just over 670,000 residents spanning over 68 square miles. The Metropolitan Police Department has been tasked with protecting these individuals. This department is the sixth largest municipal police department in the United States. The Metropolitan Police Department has a unique role in that it serves as a local police department with county, state, and federal responsibilities, and is also tasked with the protection of the President and Congress in conjunction with the Secret Service. The department is divided into 7 police districts and employs approximately 3,900 sworn officers and 450 civilian supporting staff. One major challenge that police departments constantly face is staffing enough officers to handle the anticipated number of calls that could be generated any given day while remaining within their tight budget restraints. Therefore, the objective of this analysis was to identify crime trends, including totals and locations, and encourage the Metropolitan Police Department to use this information to staff their troops efficiently. It should be stated that the goal is not to reduce police presence within the community, but to more effectively staff officers in designated locations to be able to respond more effectively to emergency calls and, as a byproduct, possibly reduce costs. When considering the problem we were trying to solve, we determined the data required to conduct this analysis needed to show the type of crime committed, the location where the crime occurred, and the time the crime was actually committed. Additionally, the data needed to span multiple years to allow us to properly identify trends in the data. The Metropolitan Police Department had previously submitted crime data to crimemaps.dc.gov, and the data was consolidated and made available through Kaggle. The data available on Kaggle ranges from January 2011 through May 2016. Once the data was downloaded to an Excel format, we were able to begin initial explorations and transformations. To help make the data more user-friendly, some transformations were necessary. Initially, several attributes were determined to be unnecessary for this project and were eliminated. Another necessary transformation was addressing missing data. After a quick review, it was determined that most of the data was complete. Data was sorted by attributes, and any line containing missing values were removed from the main dataset and evaluated for commonalities. We determined that the data with missing values were completely random and only included 2,712 lines of the 193,121 total. We decided that the best way to handle the missing data was to eliminate it, as it only totaled approximately 1.4% of the total. During our analysis, another transformation was completed. We combined different datums such as days and years to create a calculation-friendly date column that we would use to determine a specific day of the week. After initial transformations were completed, we began exploring the data. We created some particularly interesting graphs that you can see here. The graph on the top left corner shows the total number of crimes committed over the entire period, broken down by district. As you can see, districts 1, 2, and 3 reported the most crimes, while district 7 reported the least. The graph on the top right corner shows the total number of crimes committed per shift. As expected, most crimes did occur during the day and evening shifts, which usually begin at 6 o'clock a.m. and end at 10 o'clock p.m. The graph on the bottom shows the total number of crimes broken down by offense. As expected, there are far more reports of petty theft crimes shown on the left of the graph than there are violent crimes, which can be seen on the right. The creation of this box plot also provided some useful insight. The box plot breaks down the offense by district. As you can see, each offense spans across at all districts, but interestingly, the petty theft offenses, which if you recall from the previous slide were the most common, are more heavily focused in districts 1, 2, and 3, while two of the most violent crimes, arson and homicide, are heavier in districts 6 and 7.
The main focus when evaluating for choice of technique was the thought behind time playing an integral part in the data. Looking at the raw data initially did not provide any insight, but the thought that seasonality could play a role was a main focus. The resulting direction was to build a linear regression model that focused on time series forecasting. With this approach, temporal partitioning was utilized to avoid overfitting by creating training and validation data segments. The creation of partitions was essential to avoid overfitting. Additionally, the approach of using a temporal partitioning was a direct result of the time series approach. Using a cross-sectional partition would randomize the data and would create issues with the time series approach. The temporal partitioning allows for the ability to maintain past data in order to predict for current and future situations. Additionally, a temporal approach allowed for a further determination on whether or not seasonality existed within the data. One of the main areas where process repetition was evaluated was with the length of time in months to use as our validation window and to determine whether or not 2016, which was an incomplete year of data, should be incorporated into the model. The determination was made to include 2016, but to expand the validation window for 17 months. This approach provided the entirety of 2015 and the 5 months in 2016 to be utilized as the validation data. When the 2016 data was originally omitted, the resulting change was less than beneficial, and this can be tied to a situation of potentially minimal time periods utilized. This model evaluated crimes based on per month, and the data provided a total of 65 individual months worth of information. If the 5 months in 2016 were eliminated, this would result in a loss of 7.7% of the data entries. The amount of resulting data elimination was deemed unacceptable given the already limited number of data points. Figures 6 and 7 are a representation of the overall data. Figure 6 is a distribution of crimes based on per month counts for the years of 2011 through May of 2016. Figure 7 is the overall trend for the data without any type of partitions. Figure 8 is a linear regression model where the gray area represents the validation time frame of 17 months, which is 2015 through May of 2016. Figure 9 is the histogram resulting illustration of the frequency of the forecast errors for the predicted values based on their correlation to the actual values. Two main components stood out when evaluating the results. The first is that a linear regression model was not the best option to approach with this data. The utilization of a time series was a beneficial choice as it clearly helped to maintain the relationship for past and present data, but the use of a linear regression model did not provide the results we were expecting due to a lack of correlation between the dependent and independent variables. The independent variable of time did not influence the crimes in a linear fashion, and as a result, the model was attempting to fit to a linear relationship that did not exist. The better approach would have been to build the model through nonlinear regression to account for the changes in crime not resulting from a direct dependency on time. Furthermore, the validation dataset contained changes in crime rate that could not have been anticipated by the data for the training set. The beginning of the validation dataset was 2015. There was an unexpected decrease in crime during the first quarter of 2015 in comparison to other years. This decrease in crime greatly impacted the forecasting ability of the model. By maintaining the time series approach, we were able to identify that there was some seasonality within the data, in that crime tended to be lower during the earlier months of the year and spiked mid-year. This trend, while not percentage or based on a specific amount for each year, does provide some insight on the need for further exploration into how much seasonality plays a role in the crime rate. Based on an evaluation of both naive and seasonal naive evaluations for the training set and the test validation set, there was a clear distinction that the test set within the seasonal naive evaluation was much more accurate than that of just a simple naive evaluation. In summary, it is our suggestion through analysis of this data to anticipate the continual trend of increased crime. Even though the start of 2015 experienced a sharp decrease in crime, which rounded the trend line in Figure 7, the forecast indicates a steady and continual rise. Therefore, additional officers will be needed to be hired in the coming months to compensate for the additional crime. Based on the frequency of the more severe crimes, homicide, arson, sexual abuse, officers responding to these calls can respond across multiple districts. However, for the more common crimes, theft, theft with auto, specific officers should be assigned to only work these types of crimes and handle them specifically within the districts. Upon the addition of the remaining 2016 data, the model should be updated to gain a greater understanding of the forecasted future, as this additional data may show a continuation in the downward trend in crime observed in 2015. If this is the case, then the evaluation of increased crime would change. Until that point, with the information presented above, the Metropolitan Police Department of the District of Columbia should be sufficiently able to anticipate the needs to continually protect and serve the public in the short-term future. Additional research could focus on determining the overall trends in each district and development of models for individual districts. This may help to account for variable unknowns to us, such as changes in demographics and economic factors.